Thank you, everyone, for coming. So I'm Francesco. I'm the co-founder and CEO at Superfluid. We are a DeFi protocol that enables money streaming. I'll tell you a bit more what that means. The talk today is about what we can do to scale payments on-chain. So I'll start by defining payments and then kind of go through the theory of what we can do and what we do at Superfluid to make this happen. It's a bit technical. They told me that this was the technical stage, so it's a bit more technical than other talks. But even if you don't code, don't worry. It's very high level, very theoretical. So first thing I'll do is I'll just say that I think on-chain payments are the future. And while we haven't seen that many payments on crypto, it is the first use case. It's what blockchains were built for, and it offers undeniable improvements to traditional payments. So things like transparency, programmability, efficiency, traceability of payments are all things that make it much better than traditional finance. And in my opinion, there are a couple of reasons why we haven't seen as many payment startups and payment volumes on crypto, and those are mainly around compliance on one end and scalability on the other end. So I'm not going to talk to the compliance. I am going to talk to the scalability. So the first thing is I'm going to talk about recurring payments, not one-off payments. Recurring payment is when you make a payment multiple times to the same recipient over time, right? And this is very different because for traditional payments, for one-off payments like paying for coffee, there's a certain set of things you can do, and those are mostly around increasing throughput. So, I'm sure you've heard about layer 2s and all these other technologies that are basically built to make the blockchain faster. This is not what we do at Superfluid. We are scaling recurring payments. And we're already doing this. So currently there are 55,000 recurring payments set up through Superfluid, which are settling every second on-chain. So this is with current technology. It's not, it doesn't require any new layer 2s or anything like that. We're using existing blockchain technology to scale payments. So let's see how we do that. By the way, we do it with almost no cost. So I'm going to try and explain how it's possible to make recurring payments on-chain with almost no cost. So first thing, let's look at the word transaction, because this is often misunderstood. And it's very important to use the right words in order to understand what I'm talking about. So a transaction from a computer science point of view is when you change the data on a database, right? So you have a set of data, and then you change it by making a transaction. From a financial point of view, it's when you move value or money between parties. Now, for the purpose of this discussion, we're going to use the word transfer for when we move funds and transaction for when we change the database. If we're precise with language, it makes it easier to understand all the rest. And the third word that's important is settlement. So settlement is when the effects of a transaction become permanent, right? Irreversible, final. So, I want to send coffee to someone. The moment I cannot spend the money anymore, and the person on the other side can spend the money, it's final, it's settled, right? So it's when the effects become irreversible. Now, the reason I want to distinguish between these things is when I say that Superfluid works with very low cost, but we make transactions every second, people think that's impossible. However, we don't make transactions every second. We make transfers every second. Now, transactions cost gas, but transfers can be free. So when you change the data on the blockchain, you do have to pay every time. But transfers can be free if your settlement system is set up properly. And settlement is paid for by the chain. Like blockchains are settlement systems, they move forward. Whatever you do, Ethereum will create a new block, right? Every few seconds, there's a new block. We don't pay for that. It's paid through inflation. It doesn't concern the individuals making the transaction. So you pay for transactions, you don't pay for transfers, and you don't pay for settlement. So Settlement, again, going back, is when the effects of a transaction become irreversible. So the blockchain's consensus is what defines irreversibility, right? The whole system of the blockchain is made to make things that can't go back. So that is handled by the blockchain, but the effects of a transaction are defined by the blockchain in the case of the kind of standard asset. So when you're transferring Ether, the way that that transfer works is defined by the blockchain. But when you're moving tokens, it's actually defined by the token contract. So the token contract is actually what defines the way that money moves on the blockchain. And what this means is that if we change the token contract, right, we can actually change the way money moves on the blockchain, because that is what defines how transactions affect the flow of money. Am I making sense so far? Yeah? I hope so. Okay, so let's look at what a transfer is. So to define a transfer, right, I want to pay someone. So what we need is a sender, that's me, a recipient, the person I'm paying, an amount, and then when the transaction is settled on the blockchain, there's a timestamp that's attached, right? So this gives us a record. We know at a certain time, A paid B a certain amount, right? This is all the information you need. And, you know, for example, Alice pays Bob 100 units of whatever token right now. Now, there's not much we can do to make this more efficient. This information, you can't do much, right? Like, you need to know who is paying who, how much they're paying, and when they're paying. You can't change that. You can make the data more compact, you know, you can save some space, but that's about it, right? So when I said that we don't concern ourselves with one-off payments, this is what I'm referring to. However, for recurring transfers, there is a lot more we can do. So we can reduce the amount of information because some of that information is repeating, right? It's a recurring payment. So this is actually how you would make a recurring payment using a normal ERC20. You simply make a bunch of transactions, right? All those transactions are making transfers from A to B, and they all look the same. They're basically, you're writing the same data to the blockchain over and over again, right? Like, it's pretty obvious that this is not the most efficient way to do this, right? So, you know, let's see what we can get rid of. So I'd say the first thing is we can get rid of the sender and the recipient, right? Because we know who the sender is, we know who the recipient is, and they're repeating. So we can remove those, and we're already saving a lot of cost because we have to write less data to the blockchain, right? And passing data to the blockchain is what costs gas, right? So what I'm showing you here is actually more or less the data flow of a payment channel. So you might have heard of the Lightning Network or other payment channel technology. Basically, what they do is they define a sender and recipient, and then they pass value between those two entities. And by doing this, it's a very efficient way of doing payments, right? The Lightning Network is very cheap. However, it comes with a bunch of problems, and it's not great. Like, it's good, but it's not great. There are a lot of things that basically make the UX very bad. You have to lock money in the contract. It works off-chain. You have to be online the whole time. So it's good, but it's not great because it loses a lot of the composability of being on-chain, right? We think it's very important to be on-chain because that's where all the smart contracts live, and you can do more without requiring the user to run complicated systems. So what we do at Superfluid is we go a bit further from this, right? So we take those constraints, we know the sender, we know the recipient, we know the amount, and we put a constraint on the time. So we say the time, the recurring aspect, has to be every second. So the moment you put this constraint, you actually make the system incredibly scalable, because suddenly, if we know that it's going to happen every second and the amount doesn't change, our transaction becomes incredibly simple. It looks almost like a transfer, right? A sender, a recipient, an amount per second, right? It's the same amount of information as a normal transfer, but this is a payment that will go on forever. So every single second, money will flow from one account to another without any transactions, right? We only make one transaction on the blockchain where we define what's going to happen, and then it happens. right? We've optimized the way all those recurring operations, we don't need to write to the blockchain, there's no gas cost, and the money just moves, right? And we've done this by simply eliminating pieces that would repeat anyway, right? And this can happen on-chain. Like, it seems incredible, but you can actually, with the system, move money on-chain every second for absolutely no cost. So it only takes one transaction to start it. It transfers funds every second until it's stopped, and it settles every block for free on-chain. Now, this in itself is not super scalable, because this can actually be built in a number of different ways. But what's really interesting of how we built it at Superfluid is that we can have any number of incoming and outgoing streams from the same account. And this is where scalability is actually really visible, because you can have a single account receiving money from 1 million users every second for free, and sending money to 1 million users every second for free on-chain with no transactions, right? The money, again, is moving, but there are no operations actually happening on the blockchain. And this is only really possible with Superfluid. The other interesting thing for people working in payments is that these payments are net settled. To very briefly explain what that means, normally payments are gross settled in a sequence. So I pay you, and then you pay someone else with that money, right? The money has to move hands twice. With Superfluid, it doesn't. The payments actually happen at the same time. So I'm streaming money to you, you stream money to someone else, and it's the same money streaming twice at every second. It's a bit of a problem for your brain to understand that the first time, but it's actually really interesting. It's very capital efficient. So the way to make this happen is through super tokens. So super tokens are Superfluid's main product and innovation. It's an ERC20 upgrade that allows for more ways to move funds, right? And the reason for this is that the effects of transactions are defined by tokens. And ERC20 simply cannot do this. So in order to make this possible, we needed to change the token itself. So we created a new standard. It's fully compatible with the old standard, but it adds these new functionalities, right? And the most interesting thing is what we call the real-time balance. Oh, sorry, mistake. So this is the real-time balance, right? It's your balance upgrading every second. So every second, you just see your balance updating based on the streams you have open. So who's using this today? Well, our biggest user, and very, very kind of interesting product. It's a game. It's called Planet IX, and basically they're using super tokens for rentals inside their game. So you're playing this game. You want to rent some land. You open a stream, and as long as your stream is running every second, you are able to use that land, right? And since we launched with them, they basically got to 26,000 users in less than a week. And again, I want to talk again about scalability. These are 26,000 users streaming money to one contract every second with no transactions, and the money is settling at every block for free. Right? This is a very, very efficient way of doing these recurring payments, because it doesn't cost any gas to actually settle the funds, right? And 26,000 users are paying one contract, and for that contract, it really doesn't matter how many users are paying. It could be one, it could be two, it could be 1 million. For them, the cost is exactly the same, and that's why we call it a very scalable system. So there's no additional cost for the recipient, while for the sender, it's a linear cost. So if I'm streaming to you, it costs me a certain amount of gas, then I open another stream, it costs me the same amount of gas again, right? So it scales linearly, while for the recipient, it doesn't matter. They can have any number of recipients. But the interesting thing, again, is that it only costs one transaction, and after that, there are no settlement costs. So let's, again, look at Superfluid. We have these two ways of sending money, right? We have transfers and streams. Transfers happen now, while streams happen from now until you stop them, right? But as you can see, the transaction envelope is very similar amount of data, and it's very cheap, basically, to open a stream. But what if we could do more? What if our recipients were not a single account? So we take the same transaction envelope, but we change the recipient from a single account to a pool. Now, again, we're trying to make this a very compact way of making transactions, right? So by using this pool construct, we can define a set of recipients. So say I want to stream money to all of you. So I define that set of recipients, and then with one transaction, I can actually send money to the entire pool. Again, with one transaction, I can send money to an entire pool. So it's 1 million users. It doesn't matter. It costs me the same amount of money to settle with all of the pool at the same time. So you can think of things like distributing dividends or some sort of reward system. You can send money to every single recipient at the same cost. It doesn't matter if it's 10 people, 100 people, 1 million people. And this is because it's built into the transaction type. Again, it's a bit technical, but basically, these are all functionalities that are built into the token so that the token can leverage the blockchain to be incredibly scalable in settlement. So this is actually the full picture for Superfluid. It's not just transfers and streams, but it's also instant distributions and streaming distributions. So we can send money instantly or continuously, and we can send it to one recipient or to many recipients. And obviously, you know, there are different use cases, different kinds of scalability levels, but it shows you, I think, and what I'm very excited about is that this shows that if we use the blockchain a bit differently, and we think about what we're trying to do, and we rethink the way we imagine, for example, tokens, we can actually achieve a lot more than if we just replicate existing constructions on chain. Yeah, that's it for me. I hope it made sense. For any builders out there, you can go and check our docs. It's all very easy to use. The streaming distributions are on testnet at the moment, so they're not live yet. But there are already some companies that are building with them, and honestly, it's going to be very exciting. We'll be able to do things like revenue sharing. So imagine a revenue share that happens every second, right? You buy a share in a company, and every second you're receiving a part of their income, right? We can do that scalably, we can do it on chain, and we can do it without any ongoing costs. So again, it's a new world for settlement. People who are using the blockchain but trying to rebuild banking are doing it wrong. We can do a lot more interesting stuff. Thank you. Any questions?
Thank you. This is a new smart contract, so how do you port the existing token? Like, how do you bring USDC to become a super token?
Yeah, that's a good question. So there's two ways. One is you move it to a new blockchain, and on that blockchain you deploy it as a super token. And the other is that you're on the same blockchain, but you have a wrapper. And then you just kind of swap between the wrapper and the normal token. The third way, if the token doesn't exist yet, is just you issue it through Superfluid.
Maybe follow up, like, are you planning to do wrapping yourself?
So we've never actually deployed a single token, but our community has deployed almost 400 tokens. So you can find pretty much whatever you need.
I have a question. So it seems to me that the key enabler, what unlocked this scalability, was to remove the information on, let's say, irregular intervals. So you have these payments every second or whatever interval that you want to have regularly. And I mean, this is brilliant, really. I really enjoyed the presentation. I'm just asking myself, what kind of use cases wouldn't work with this kind of limitation? Because, you know, there is always a trade-off, I guess. So Is there anything that doesn't work? Because it doesn't come to mind now. It looks like it works for everything, but maybe on demand, spikes in demand, I don't know.
Yeah, I mean, it works for what it works. Look, the world is not organized in this way, right? We want to reorganize it in this way, but it's not, right? If I ask you, how many days are in a month, right? There's not a straight answer. Every month is different, right? So even for something as simple as salaries, every month has a different duration, a different amount. The world is full of bumps and irregularities. What I was trying to show is that if we did reorganize payments around this, there are some incredible efficiency gains, right? So it seems like it would make sense. But as always with crypto stuff, there's a big difference between the practical and the theoretical, right? And between the technical implementation and the applicability. So it's useful for a lot of things, but then compliance happens, which is why at the beginning I said I'm not talking about compliance. Because, for example, for employment law, this often clashes, right? Our company is incorporated in the UK, and in the UK you have to make a declaration every time you pay an employee, right? We're paying our employees pretty often, right? I don't know if they can handle this amount of declarations, right? So unfortunately the system has to adapt, right? And I do believe that this technology is here to stay. It's very efficient, it's very scalable, but the world usually takes a bit longer to catch up.
Thank you.
Hey, thanks for the speech. It was great. I think it's really interesting what you guys are doing. I don't know if I got it right, but I want to understand, like, I don't know, 10 months ago I read an article from Visa and Starknet about using account abstraction in ZK to do recurring payments, and I wanted to understand what's the trade-off between using Superfluid or using that kind of technology?
Yeah, so this is a very good question. People often misunderstand, and I think it's because we don't have the right words to explain this, but I'll do my best. So when we talk about automation, right, what Visa is doing is automation. Account abstraction allows you to delegate automation to someone else, and then someone else makes transfers for you, right? They're making normal transfers. They're not doing anything fancy. What they're innovating on is actually the delegation, right? Now, automation usually means I will make someone else do something for me. In the case of Superfluid, there is no someone else. When you open a stream, it's between you and the recipient. There is no third party that's making it happen, right? So I think I like to say that this is autonomous payments compared to automated payments. The same way you can think of, Uniswap as an automated market maker compared to, maybe an, I don't know, something else, right? Again, we don't have good words to describe this, but there's no third parties here. And I'd say that's the big thing. Obviously, Visa's business is to be a third party, so, it's not our business. We build technology.
All right, guys, the time is up, unfortunately, so we have to.
Thank you, everyone.